Hey guys, welcome to Code Decode. Today in this video, we will be looking into some very important SQL based interview question asked to Java and full stack developers. So let's get started. Whenever it comes to SQL, the first thing which comes to your mind is joins, and different types of joins you must have used in SQL. So we have multiple tables in the database. Now giving a proper view to your customers by creating joins between different tables is a trickier part of any RDBMS systems. Hence, SQL joins are very important part to retrieve relevant data from multiple tables to give a meaningful result set to your consumers or downstream systems. So SQL joins are used to retrieve data from multiple tables, combining them and fetching only a meaningful result set which will be helpful for your consumers or downstream systems. It is performed whenever you need to fetch records from two or more tables. There are multiple type of joins available in SQL. We will be seeing all of them. The joins are InnerJoin, self-join, left outer join, right outer join, full outer join and cross join. In these, most of the time what we use is inner, left outer, right outer and full join, and self and cross joins are used in very specific conditions. So we will be seeing all these scenarios in a real-time situation where I have created two tables for you. Employee table. This employee table has ID, name and department to which this particular employee belongs to, and a department table that is ID and name of that department. So one department can have multiple employees available. So for example, for the department number 2, that is inventory, we have two employees in our database, Decode and Code Decode. Remember one thing, I have kept foreign keys as empty. Whenever you try to recreate this example, keep foreign keys as empty. Though I understand that it is a requirement that this department ID should be a foreign key for this department table. But if I would have done that, I would not be able to show you proper join examples. So let's go ahead with this example. We will see all these kinds of joins now. Hey people, if you're interested in full stack courses, or if you're someone who is currently working but not enjoying your job, I have an exciting opportunity for you. There is an amazing upskill platform that helps people launch and grow their careers as a full stack software developer. They have partnership with multiple industries which will help you get jobs. The full stack software development, as you might all know, is the hottest job in the IT industry right now. So if you would like to kickstart your career in this field, join OdinSchool today. Then next cohort starts on 29th of January 2023. They also provide 100% placement assistance. You can also see their awesome placement success stories here. OdinSchool's successful graduates are a mix of both freshers and experienced who come from very diverse backgrounds. OdinSchool's also negotiates on behalf of you people for your better salary packages. They also have 7 days refund policy with prepaid and postpaid, both of the payment models. The cost of this course is around 30,000 plus GST, and the salary packages will also range from 5 lakhs to 25 lakhs. The main highlight of this bootcamp is they have live interactive sessions with experienced instructors, rigorous classes every weekends, regular interaction with industry experts, product-based hands-on learnings, and interview preparation and placement assistance. Anyone above 21 years of age can apply, be it fresher, be it experience, doesn't matter. So OdinSchool is definitely one of the best platform for you to get yourself skilled in promising domain of full stack software development. Let's start with a very important one, InnerJoin. InnerJoin returns only those rows from the table that the specific condition matches and hide other rows and columns. Now this means that only matching rows will be returned. I'll give you an example of this Venn diagram. There is an employee table, there is a department table. Few employees and departments have the common values. For example, here these are the department. So we are going to write a join. So I have written a join on employee table, inner join with department table on department ID equals to employee.department ID equals to department.department ID. So this is the employee.department ID which shows where each employee belongs to which department. And this is a department table which shows the unique IDs here. So what common we have? Here we have 1, 2 and 3 as a department ID. But here we have only 1, 2 and 5. So the common ones between 1, 2, 5 and 1, 2, 3 is only 1 and 2. So in our result, we should not have any 3 orders as the department, and we should also not have EMP as employee because 5 is not the common one. The only common one is these 3 rows which is matching with these 2 rows. So in the output we are going to have total of only 3 rows which are common ones. So in this Venn diagram only this part which is common is going to be the output and the result, and none of these greenish and orangish part. So when I try to run this join, I should have only 3 rows: code, decode and code decode, because these are only matching department IDs. So let's try running this. This is the output we get. We have code, decode and code decode as expected, because only 1, 2 are common between both employee and department table. The 3 is not available here in any of the department rows, and 5 is not available in the department ID rows. Hence the common ones is the output for us. So InnerJoin returns only those records that matches the specified condition, where the condition was department ID of employee should be equal to department ID of department table. And it hide other rows and columns. So what rows were hidden? So this row with 5 as a department ID is hidden, and this row as a 3 department ID is hidden because they do not have it common or matching with each other. So it fetches rows that is at least one match of row between both the tables are found. And InnerJoin keyword joins the matching records of the 2 tables. Here the 2 tables were employee table and department table, and the joining conditions were employee.department ID equals to department.department ID. So only matching ones were the return of InnerJoin. It is assumed as default join, so it is optional to use InnerJoin with the query. Now this is pre-assumed that when you join 2 tables, it will be for sure an InnerJoin. So I can also do a comma separation with a where clause, which will also return you the same thing, and removing the inner from here. So inner was an optional one, it is the default one. So you can remove the inner keyword from the query and still it will return you the same result. So this is the same result as you got earlier. So that's the beauty of InnerJoin. InnerJoin is a default one. The syntax was shown here. Select what all columns you need to select from the 2 tables, joining them on and on the condition. So I want the condition that this department ID should be equals to the primary key or the ID of this. So on the condition is very important. If you do not put this on condition, you will get a Cartesian join of all of these. So on condition is very much important when it comes to joins. Now next comes RightJoin in SQL. Now what is RightJoin? RightJoin says when it comes to Venn diagram, this is the left and this is the right one. So when we do the RightJoin, all the common comes in the result, but also all the rows which are in the right will also come in the result. So if you can see, the whole orange part will be your output. Only the right one will be there and the common ones will be there. So it is used to retrieve all rows from the right table and only rows from the other table who is fulfilling the join condition and matching with it. And let me give you an example. Here I have on the left hand side employee table and on the right hand side department table. So if I do right outer join, then all the rows of department table will come. So what are the rows? There are 3 rows. So initially in the inner join, the 3rd row didn't come. But now since we are doing the right outer join, even the 3rd row will come with null as the employee being connected to that. But on the left table, only the common ones or the inner join output will come. So in this, only the common ones are 1 and 2. 5 is not there in the right table. So 5 will not come, because it is not a left outer join or full outer join, it is right outer join. The focus will be given on all the rows of the right table and only the matching from the left table. So output should be 1, 2, 3 for department table, but only 1 and 2 which are common in both the tables from the employee table. So output will be 1 code, 2 decode, 3 code decode and 3 orders. So let's try this. Great. So we have 1 code, 2 decode, 3 code decode, but null for the 3 orders. So this 1, 2 and 3 are the all rows possible in the department table 1, 2, 3, but only the common ones, that is code, decode and code decode. So that is code, decode and code decode here, and the null values here. So that's right outer join. So it returns all the rows from the right hand side table, that is department table, that was 1, 2, 3. And even though there are no matching ones for the left hand side. So yes, we did not have any matching ones. So this 3 orders did not have any matching column in the employee table. Still, it came into the result set with all the null as the employee information, because there was no employee which was assigned to this third department. Hence everything null came as a output in the result set. It finds unmatched records from the left hand side and returns a null value. So yes, we have seen it returns a null value for those in the left hand side which is not matching with the one with the right hand side records. This is also known as right outer join. You can also put it as right join, still the output will be the same one. And the syntax was select. So I have selected everything from table 1, right join and table 2. So remember, what is on the right hand side of your table will have all the rows in the output, and only the common one from the left hand side will be there. The on condition is also very important. That will show you on which particular rows the equality is kept to fetch the records. Now the left outer join, it fetches all the rows from the left table and only the common from the right table. So again, if I just remove it and do the left outer join, then now 3 should not come and employee 5 should come into picture, because 5 is there in the employee table and we are doing the left outer join. So every row of the left table will come. That means code, decode and employee, all the 4 employees will come in the output result, but only common ones. So who are the common ones? 1 and 2 are the common ones. So only sales and inventory will come in the output result. Orders will not be the part of the output as it was there in the right outer join. So let's run this. And yes, we have all the 4 employees in the output with the department IDs, and when you do not have the corresponding department in the department table, you will have null, but 3 will not be the part of department table. So only sales and inventory will come, orders will not come, because of the left outer join only the matching column of the right table will come, and hence it returns all the rows from the left hand side table. So 1, 2 and 5, all the rows 1, 2 and 5 comes into the output, though there are no matching columns on the right side table. So 5 does not have any matching column. There was no 5 in a department table. Hence the null is returned for that particular row. So hence null as was returned for the employee with department 5. This join is also called left outer join, or if you remove this outer part, then also your output will remain the same. It is also called as left join or left outer join. And the syntax is again the same. The left hand side table is given the priority and the right hand side table has only the common ones, which is with the left one, and on condition is required to compare the equality. Now a very important part, what is full join in SQL? So full join is a combination of both left, right and the common ones. So in this Venn diagram, for the left outer join, we have employee tables, all rows and the common ones of the right. In the right outer join, we have all the rows for the department table and only common of the employee and department table. But in the full outer join, you have all rows from employee table, all rows for department table, and the corresponding common ones will come in front of each other. So everything in this Venn diagram will be coming as a full outer join as an output. Now let me give you an example. So in our output, all the 4 rows from here also will come and all the 3 rows from here also will come. Remember one place where we all go wrong. These are the join syntaxes of SQL and not MySQL. Now when you try to put left outer join, things will work. When you try to put right outer join, it will work in MySQL. But when you try to put full outer join, this code will not work. This query will not work. It will give you syntax error. When you even try to put it with outer join, this syntax will also not work. Reason being, this full outer join is a syntax for SQL and not for MySQL. Now what I can do is, since full outer join is not a keyword, reserved keyword in MySQL, I need anyways a result of full outer join. So what is a workaround in MySQL for this full outer join not working as a keyword, existing keyword? To get the same result, you need to do the union of left outer join and right outer join. Something like left outer join and right outer joins union. So let me show that also to you. Let me keep it as left outer join only. Let me create one more select query with right outer join and do the union of both. And now with this particular query of left and right outer joins result set union, you will get all the rows of left side, all the rows of right side, and also the common ones of left and right one. So common one will be 1, 2 and 2, that is code, decode and decode. These are the common ones, but also employee 5 with department as null and department 3 with orders and employee as null. When you try to run this, it's full outer join. Every row from left is also in this result set, every row from the right is also in the result set, and the common ones are in front of each other, joined with each other. That's full outer join for you. Now the next is self join, and what is the requirement of self join? So self join is used to join a table with itself. So it is our task to understand from the question given by an interviewer to find if we need left outer join, right outer join, inner join or self join. Now suppose an example, an interviewer asks you that you are given an employee table and you need to find all the employees belonging to same department. So here when you try to run all the rows of the employee table, you can see that decode and code decode belongs to the same department. Now what interviewer asks you is to fetch only those records who belongs to the same department. So decode and code decode belongs to the same department, that is department number 2. So that is the output needed. Now we don't need any other table to fetch this output because all the rows that we need and the condition is here only. Here is the case when we need a self join, when we need to join the same table twice and fetch only those records who are belonging to the same department. So fetch all employees belonging to the same department. Now let's see the approach how to do it, and then we will do it. I have two queries, same queries, fetch star everything from employee table and fetch everything from employee table. Now try and understand this query, okay? What I need is, I need to fetch the common ones, the one who are belonging to the same department. So what I can do is join this table employee with the same table employee with a different alias and check if the department IDs are same. So here let's try from the first row, okay? So employee E1 starts here and check for employee table E2 and check in any of the case it has any row with department 1. So yes, there is a case with department 1, but the ID is same. So what I can put a condition is, I need the department ID to be same, but my ID should be different. So can I write a query like select everything from employee table EMP and the same employee table EMP2 where departments are same but employee IDs are different. So what will happen? When I try to merge this 4 rows with these 4 rows, I'll be joining the first row with all the rows of the second EMP table. So starting from the first row, is my department same but is my employee ID different? So in the first case, yes, my department are same 1 but employee ID is same, hence cannot be taken into account. So code is not matched yet. Now it goes to the next row of the second table EMP2 and check is the department ID equal. No, the department ID here is 1 and here it is 2. Similarly, it goes to third row, it is 2. It goes to fourth row, it is 5. So it doesn't find any of the row such that the department ID is 1 but employee ID is different. So 1 is out of the context, it's not going to come into our output. It goes to the second row of the first table EMP1 and check whether this department ID is matching for the first row. It says EMP2 doesn't have it in the first row, it goes to second row, yes it matches. So the department ID 2 matches with department ID 2 but ID is also same. So this gets false, the employee ID should be different. So again it is not working on the second row. So it goes to the employee table's third row. Is the department ID same as 2? Yes, department ID is same as 2. Here also the department ID is 2 and here also department ID is 2. And is the ID different? Yes, the here ID is 2 and here ID is 3. This qualifies for our result, and when running this comes into our output. So code decode comes into our output with this matching row. But when it comes to 4, is the department ID same? No, it is not 2, it doesn't match. Now next it goes to 3 and check whether the department ID is 2 and starts from the first row. So is it 2? No. Is it 2? Yes. But is the ID different? Yes, here the ID it is matching is 3, here the ID it is matching is 2. So again this also comes into the row as decode. The last one is cross join. Cross join is a simple one. If you have two different tables, you can use cross join to combine two different tables, and that will be actually the Cartesian product of set of all the rows, where each row will be combined with each row of the second table. Now let me give you an example here. I have an employee table, I have department table, and I'm going to do the Cartesian join. So what is the syntax for it? The syntax is a cross join or simple comma. So I'll give a simple syntax, a simple comma, and remove all the conditions. Now what will happen? All the rows of employee will be Cartesian joined with all the rows of department table. Here I have 4 rows will be combined with all the 3 rows. So Cartesian product will be there. So 4th is a 12, 12 rows should be output. So if you can see the output, there are 12 rows here. 3 rows for 1, 3 rows for 2, 3 rows for 3, 3 rows for 4. So 4 into 3, 12. So Cartesian product happened. What happened here? The code with ID 1 is matched with all the 3 rows of department. So for ID 1, all the 3 rows are matched for the department. For ID 2, all the 3 rows for department is matched. For ID 3 employee, all the 3 department rows are matched. Or the ID 4, all the 3 rows are matched. So that's the Cartesian product. That is just each row of employee table combined with each row of the department table, and that's the cross join. And the total number of rows will be number of rows present in 1 into, and that is the product of the number of rows present in 2. So product of rows present in 1 and 2 is 4 into 3, that is 12. So these are total of 12 rows. So I can also show you the count, that's the aggregate, and you can see the 12 rows are coming as the Cartesian join. Also one more syntax for Cartesian join or cross join is writing cross join, or the simple one, put a comma, and with no condition, no on, no where, nothing, and then it becomes a Cartesian join where each row of employee will be mapped with each row of department table. So that was all about the joins. I have many things to cover. What is primary key, what is foreign key, which we will be covering in the next video if you want me to cover. And also we have many such questions like given 2 tables, fetch only managers. There are multiple scenario based questions. So if you want me to cover all those scenario based questions which are asked in interviews, just let me know in the comment section. I'll create one more video on that. Thank you.